So the first thing that you're going to have to do is write out some lines of Pascal's triangle. I've told you that I won't go higher than the fifth power, so you only need to write out the first 5 lines. Bless you. So the first line, bless you, is actually like the 0th line. Anything to the 0 power would just be 1. So this is the first line. What's the second line going to be? Yeah, 1, 2, 1. You're just adding what's above. So then you'd have 1, 3, 3, 1. Again, we're just adding these. So 1 plus 2 gives you 3. That's how you get that. What would the fourth line be? Yeah, 1, 4, 6, 4, 1. And then you'll have 1, 5, 10, 10. Good. 5, 1. Obviously, it goes on infinitely. Numbers don't stop. That's as far as I'm going to have you go, though. So again, we'll do the first one together. And then I'll kind of be quiet and let you try the other ones with your group. I'm going to color code again. So when I take a picture of this and put it on Schoology, it'll be color coded. I know it doesn't show up real great up here. But the power tells you what line of the triangle you want. And then those are your coefficients. So since this says to the 4th, we're going to take the line with the 4 in it, right? 1, 4, 6, 4, 1. So go ahead and write those out. All right, and then we're going to start with whatever's first in the parentheses to that power. So it would be x to the 4th, and then what happens when you fill in the rest of it? Yeah, it's going to go down. It's descending. So then we'll have x to the 3rd, x to the 2nd, x to the 1st, oops, x to the nothing. I almost just wrote a 0, I'm sorry. X to the nothing, which actually you don't technically need to write it all anyway, because that's going to go away. And then you're going to have the second part, but it's going to go the other way. So it'll be 1 to the nothing, 1 to the 1st, 1 to the 2nd, 1 to the 3rd, 1 to the 4th. And then you're just going to put a whole bunch of plus signs in between those. Now this one's actually going to be kind of easy to simplify because I threw a 1 in there. What's 1 to any power? 1. So they're all going to kind of be easy to simplify. If you want to scribble out anything to the 0th power, some people like to do that because it's going to go away. And so essentially it's a 2-step problem. Like that's the answer. Now we're just going to simplify it down. So this will be x to the 4th plus 4x cubed plus 6x squared plus 4x plus, oh, what's that last part? Yeah, that'll just be 1. So take a few minutes. I'm just going to pause the recording. Try 2, 3, 4, and 5. After like a couple minutes go by, I'll write up the answer for 2. After a couple minutes go by, I'll write up the answer for 3 so you guys can check them. And just call me over if you have a question. But like I should hear you talking to each other in your groups. And we're just reviewing what we did last time.
I was doing, hold on, I was doing negative 2 times. Nope, what you did was, that's higher than my grade. 4. 1. But there's no way you're gonna get 7. You're lying right now. You are, you have 67. You are lying so hard. 67.
Hey guys, just focus on what you're doing, okay? All right, I'm writing up the second one. And I'm just going to scribble out the stuff to the 0 power. Now, what you can do with the negatives is, if you notice, they alternate. So if the negative is what's getting you caught up, you can honestly just write it as a positive 2. And then at the end, just make it alternate. Do you get what I'm saying there? Like if the negative is what's bothering you, you can write all of these as a positive 2. And then at the end, just go positive, negative, positive, negative. Are you like following me? Okay. So this would be x to the 5th. Now this would be negative 2 times 5. So minus 10x to the 4th. Negative 2 squared would be positive 4 times 10 would be 40 x to the 3rd. What's this next one? It will be negative. Good. 80 x squared. This will be positive. Negative 2 to the 4th would be positive 16 times 5 would be 80x. And then negative 2 to the 5th would be negative 32. But again, do you see how it alternates? It's always going to start out positive. Like the first term will always be positive. Positive, negative, positive, negative, positive, negative. So if the negative in there is what bothers you, just kind of ignore it, I guess. And then at the end, you can just make them alternate.
2x.
You have to add the one.
It'd be
too.
16, 17.
Did you add the one?
Where?
So we just add the one? No. You multiply.
What's 2 to the 4th power?
16.
Yes,
Times 1.
So it'd be 17. Oh,
Or do you add it?
or you multiply it. So
Hold
it'd
on.
be 16. We're lost. 16.
I'm going over it right now, so if you want to watch up here, let me just finish writing it out.
Yeah,
Let's
so
get you.
you're not the thing with it. It is James.
All right, guys, if you want to watch me simplify this one, I'm going to go through it. Anything to the 0, you can scribble out. That's going to just be gone. Now, you have to put parentheses around the 2x because the whole thing is getting taken to the 4th. So watch. If you wanted to check your answer on this one, if you're still working ahead, that's fine. 2 to the 4th would be 16, and then the x is also to the 4th. It's the whole thing being taken to the 4th. So, like, watch me point to this one. You're doing 2 to the 3rd. That's not 6. What is that? 2 to the 3rd is 8 times 4, 32, x to the 3rd. It's nice that I gave you a 1, right? I did that on purpose because if you multiply by 1, it's not going to change anything. All right, here, 2 squared. Be 4 times 6, 24x squared. All right, 2 to the 1st would just be 2 times 4 is 8x. And then what's the last term? 1. It would just be 1. That's it. No, it's not that fun. They're only 2-step problems. Again, take another minute and try number 4. I'm just going through them like as it seems like everyone's kind of finished each one so you can check your answer. So for the 3rd power, what are going to be your coefficients for that? 1, 3, 3, 1. So this one's actually kind of shorter. All right, and then we're going to start with x to the 3rd. So x to the 3rd, x to the 2nd, x to the 1st, x to the nothing. Now, it would be negative y to the 3rd, but here, watch. This is what I was saying before. If the negative is what's bothering you, just ignore it. Let me show you how to do this. You can just use y. It'll be y to the 0, y to the 1st, y to the 2nd, y to the 3rd. But then instead of putting all plus signs, watch. The first one's always going to be positive. I'm sorry, that was a 0. That didn't not very good. This one would be positive, so this one would be negative, and then this one would be positive, and then this one would be negative. So if you're getting hung up on the negatives, you can do that too. That's another like totally valid way to get through that. The first one is always positive. It will always start positive. So if you have a negative in there, you can kind of just ignore that. Like I just used positive y, and then I just made them alternate. So this first term would just be x to the 3rd. And actually, none of this is going to simplify down, really, isn't it? I'm just going to write it without all the silly little ones in there and everything. How come that one really didn't have any math? It was just variable. There weren't any numbers. So there's actually like no math in that one. So that's kind of nice. There weren't any numbers. All right. And then last one, coefficients are also going to be 1, 3, 3, 1. And again, we're going to start with x to the 3rd, and then it's going to descend. And now this one is 2y. So just make sure you put parentheses around it. So see how I started with 2y to the nothing? It's going to be the same for the others as well. Like you need to quantify that. And then I'll put the plus signs in between. When it's only to the 3rd power, it's not too bad. All right, so I'm going to scribble out the stuff that's to the 0. That's going to just go away. First term will just be x to the 3rd. Let's look at the next one. Remember, you have to do the exponent first. So watch me point to it. 2 to the 1st is 2 times 3.
Oh, well, 6.
6. X squared y. You are the only one talking to me, so gold star. No one else said anything. So, all right, plus. Now look at this one. 2 squared. 4 times 3, 12. So this will be 12xy squared. And then the last one, 2 cubed is 8, and then y cubed. We remember this okay from last time? Okay. All right, so the next thing that we're gonna start looking at this unit are rational graphs. My goal is for us to get through half of these today, or like the first four. I want to get through the first four. As a heads up, the first one we do is gonna take longer because I'm explaining to you how to find everything. After that, it will go a little bit quicker. Does this make sense? Because you're gonna be like, oh my gosh, it's gonna take forever to do every problem. No, the first one's gonna take a minute because I'm gonna explain everything to you. Okay, so they're not all gonna take up. So I'm gonna write this on a separate sheet of paper. You can if you want to, or if you just pay attention. I'm gonna go through the order I would suggest doing these in. And the first thing that I would do is the domain. And we have talked about this before this year. You have to exclude, and I know that kind of feels rude, like we're excluding. You're going to exclude where the denominator is 0. You are not allowed to divide by 0. I call these numbers the troublemakers. Kick them out. You are not allowed to divide by 0. Okay, so let's apply that to this problem. What number is not, who is not invited to the domain party? -2 is a troublemaker. Kick him out. Do you get why we picked -2? Because +2 would be 0. So how do we write that though, that we want to kick out -2? It involves some parentheses. There is going to be a union in it. You did this on the Unit 2 test. I actually gave you one of these graphs on the Unit 2 test. You did it successfully. How do we kick out -2? Good, -infinity to -2, parentheses, because you want to leave it out. Good, good, we got there. Nice teamwork. What this is saying is you want everything to the left of -2, everything to the right of -2, but not -2. You are kicking it out. Now, after the domain, and this is my suggestion, you can take it or leave it. After the domain, I would do the whole and the vertical asymptote, because those three things all kind of go together. Whatever values you have excluded from the domain, like once those troublemakers have been kicked out, it's like you've excommunicated them. You're like, booted them out, they're gone. There's only 2 career paths available to them. They can be a whole or they can be a vertical asymptote. So this -2 that we kicked out, it can be one of those 2 things. How do we tell the difference? If something cancels out, then it becomes a whole. And if it doesn't cancel out, oops, I can't write. If it doesn't cancel out, then it's going to be a vertical asymptote. So applying that to this problem, does anything cancel out? Did we slash anything out on the numerator and the denominator? No. So which one of these is it going to become? Vertical asymptote. Nothing canceled out, so there won't be a hole in the graph. Did you guys graph things with holes in them last year? Remember you put the little donut in the graph? Okay, it happened. I know that that's in algebra 2. There won't be a hole. Instead, it's going to be a vertical asymptote. The -2 that we kicked out is what I'm talking about, our troublemaker. Oh, and I heard somebody say it. It's going to be x equals. That's your Hoivux. So x equals -2. And then what you can do is over here on the graph, dot that in at -2. I build the graph as I come up with the stuff, because then it's like you're doing it one piece at a time. So that's my suggestion. Do those 3 things together. Whatever gets excluded from the domain, it's going to either become a whole or a vertical asymptote. So those 3 things kind of go together. All right. Then I would try and get the other asymptote, the horizontal or slant asymptote. This is the new thing that you did not do last year. You did not do slant asymptotes last year, and I'll explain why it's not in the Algebra 2 curriculum, but that's new, okay? That's the new thing. You compare the degree of the numerator and denominator. So there's 3 ways it can turn out. If your numerator degree is smaller than your denominator degree, it is a horizontal asymptote, and it is automatically y equals 0. Here's how my brain does this. Here's how I remember that. When you do a horizontal asymptote, you're going out to the sides, like the ends, like to infinity, right? Do you get what I'm saying? Like our brains really can't process infinity, so don't like try too hard. But anyway, if the numerator is smaller than the denominator, here's the situation that you get. Are you ready? As you go out towards big numbers, a half, a third, a fourth, a fifth, a sixth, a seventh, an eighth, a ninth. Are you following me? Until you get out to 1/1,000,000th. And if I offered you 1/1,000,000,000th of a cookie, you would be like, gee, thanks, Miss Cole, because that is nothing, okay? It's gonna level off at nothing. As you go to the bigger and bigger numbers, it's gonna end up going to 0. If your numerator degree equals your denominator degree, that's also gonna be a horizontal asymptote. It's y, does anyone remember when it's a tie, what do you use? I'm just throwing the question out there because you did do it last year. Not 1, it oftentimes ends up becoming 1 weirdly, but you use the coefficients. Do you remember that? Like just whatever numbers are there, like you use that kind of as a tiebreaker. So y equals your coefficients. So what's the third way that can turn out? If the numerator is greater than the denominator, that's where you're going to have a slant asymptote. Again, that's the new thing. And it's going to be y equals, and here's why you don't learn it in Algebra 2. You're going to do your synthetic division, which you were all really great at. You should be like happy about that. That was the thing you nailed on the test you just took. Put a number in the little box, divide it out. Okay, so that's the new thing. So let's apply this, and this all kind of goes together. So let's apply that to this problem. Degree of the numerator. Do you see an x there at all? No, it's really x to the nothing. The power is 0. What's the degree on the denominator? This is x to the 1. 0 is smaller than 1. So which one of these situations have we got? The first one, good. It's automatically y equals 0. So you're going to have a horizontal asymptote, y equals 0, and you can go ahead and dot that in. It's hard to see when it's 0 because it's like on the axes, but just do your best. All right, after that, you want to get some points to plot on your graph. So the next thing I would look at are the intercepts. So your x-intercept is going to be something, comma, 0. And your y-intercept is going to be what? 0, comma, something. So I would do those kind of together. So x-intercept, something 0. Let's apply that to this problem. If you set this equation equal to 0, let me just take the whole thing and make it equal 0. What would you do to start solving that? You would multiply the x plus 2 over, but 0 times x plus 2 would just be 0. You would get 3 equals 0. Thoughts on that? Yeah, that's just not going to work, right? So there just isn't one. And why does that make sense as far as this picture goes? Yeah, there's the asymptote. And as I just said, sometimes when you do really weird stuff, it can go through. I'm obviously not going to do the hardest example first. I'm going to start out with an easier one. So there just won't be one. Yes, that just didn't work out. Y-intercept, we will get one of those. You're going to plug in 0 for x. So if you plug in 0 for x, what do you get? You get 3 over 2. Now, you can't graph that like perfectly, but it'll be like good enough. 3 over 2 is what, like as a decimal? 1.5. So as long as you put it in between 1 and 2, then you're good. Now, once you get that stuff, draw the graph. Okay, and it's going to be like good enough. Okay, as long as you don't run into the asymptotes, you're going to go through this point. It's the only point we have. It's going to do something like this. And then the other arm of it will be down here. You can try and plot more points if you feel like it, but I don't require it. That's like good enough. And then you're going to go back and pick up all the rest of this stuff. Okay, so the range. You're going to exclude the whole because it would be missing just the y value. Why the y value? You're leaving out the whole because it's missing, right? The whole. All right, but how come the y value? Because it's the range. Range is y value. So you would exclude the whole and the horizontal asymptote because that's where it's leveling off. It won't ever touch there. But essentially, you can just scan downwards to upwards. Here, watch. Just watch. You guys are like really. All right, so we're going to scan downwards to upwards. Does this graph go down forever?
Yeah.
Yes, good. It goes upwards forever, but who is not invited to the range party? Who is getting left out? 0. Leave 0 out. We want everything to the left of 0, everything to the right of 0, but not 0. So make sure you put parentheses on that. Increasing and decreasing. Only thing I'm going to say about that is you have to read it what direction. Left to right. So you're going to use the domain. Domain is X, that's left to right. Will you ever copy over the range? No, because it's left to right. So we're just going to use the domain for that. All right, so hey guys, watch, I'll point to it. As we read left to right, what's the graph doing? Yeah, decreasing, and still over here it is decreasing. So increasing is none. For decreasing, just copy over the domain. And if your domain is wrong, but you copy it over for decreasing, I'll give you credit for it here. Now, end behavior, I'm going to start requiring it that you write it the correct way. Okay, I kind of like let it go in the first quarter, but we're going to need to start writing it correctly. Only thing I'm going to say about the ends here, it will be the horizontal asymptote if there is one. If there's not, then obviously that's not the case. But if you have a horizontal asymptote at, give me a number, 6. Okay, say it levels off at 6. Then both the ends go to 6. Does this make sense?
Yeah.
Like it's gonna be the same answer. You can just repeat it. Now, where was this horizontal asymptote? Like, let's apply that to this problem. Yeah, and if you cover up the middle of the graph, you see how both these arrows go to 0? Okay, this one's leveling off at 0 and this one's leveling. Will it ever actually touch 0? No, but it is behavior. Okay, so it's limit as x goes to negative infinity of the function and limit as x goes to positive infinity of the function. And they're both 0. Both sides are leveling off at 0. Now that one took a while because I was spending the time explaining all of the stuff to you. But this next one shouldn't be like as labor intensive. Now, before you can start pulling this apart and answering any of the questions, what do you have to do to these? Factor, good. I'm going to pause the video. I want you to go ahead and factor those with your group, share, make sure you all get the same thing. All right, what did you get for the numerator? Good, x plus 3, x minus 3. If you wrote the minus here and the plus here, is that okay? What is that called? You're the only one talking to me, so a difference of squares. There we go. All right, and then down here, how did you split that one? Did you get 1 and 3? Plus 1. Perfect. Okay. Do this in the order I went over it. First, do the domain. There are 2 troublemakers. Who is getting not invited to the domain party? These, you want to look at positive 3 and negative 1. Now you have to do it like left to right. So you're going to have to leave out the negative 1 first and then the 3. The more troublemakers you have, the longer that answer gets because you just keep on linking them all together. But we're leaving out negative 1 and we're leaving out 3. We want everything to the left of negative 1, everything between negative 1 and 3, everything beyond 3, but not negative 1 and 3. I don't go beyond just leaving out 2 numbers, but do you get how in theory, the more of them you leave out, the more little unions you're going to have? Like in theory, it could go for, I'm trying to think if I do one that goes beyond 2. I really don't think I do. All right, now what 2 things did I say to do next? What goes with that? Whole and vertical asymptote. Whole is if it cancels. Vertical asymptote is if it doesn't. So does something cancel? Yes. 3 becomes the whole. How do you get the other part of it though? Because it's 3 comma something. What do? We do not set it equal to 0, but that was a good guess. Plug in 3. So let's see what we get when we plug 3 back in. 3 plus 3 would be 6. 3 plus 1 would be 4. Oh, actually that reduces. 6/4 be 3/2, which as we said is 1 1/2. Good enough, Okay, you're gonna put a hole, which looks like a little donut at 3, 1.5. So that would be like right about there. Just do your best. If it's between 1 and 2, it's fine. Like good enough, right? Not grading your art skills. So 3 was one of our troublemakers. That became the hole. What is -1 gonna do? Good, which asymptote? Vertical, so it's gonna be x equals -1, and then you can dot that in. So do those 3 things together. Maybe just put a little star next to those 3. Do those 3 things together. Whatever gets kicked out of the domain, it can become one of these. If it cancels, it's a hole. If it doesn't cancel, it's a vertical asymptote. What did I suggest you do next? After we get this asymptote, we should get okay, so you're going to compare the powers. Look at what's the power on the numerator? 2. What's the power on the denominator? 2. When it's a tie, you use the coefficient, which, as you said, it oftentimes does become 1. Do you see how these are both 1? Like nothing's written, and 1/1 is 1. So y equals 1. And you want to just dot it in at the edges. Because again, if the graph happens to do something really strange in between, it always ends up bothering people if the graph goes through it. So just dot it at the edges. It's just like the wings of the graph. Now I want some points on my graph. So let's go back and do the intercepts. X-intercept is something 0. You're going to take this and make it equal 0. You're going to set it equal to 0. So if I take that and set it equal to 0, how would we start solving? Good. Now, when you multiply that over, what do you get? 0. So it's just x plus 3 equals 0. That'll give you -3. Go ahead and put that on the grid. It'll be right there. Good. Does it matter if you plug into the original problem or the factored one? No, it really doesn't. In fact, usually I'll just cover up the x's and be like, here's what's left. -9 over -3. Yeah, exactly. It'll work every time. Because if there's 0, you can just cover them up. -9 over -3 would be 3. If you look at the factored version, same thing happens. If you cover up the x's, you get 3/1, just 3. It's not going to make a difference which one you use. And at that point, you can go ahead and connect it. Can you please listen to me on this part? The hole is missing from the graph, but you still have to incorporate it into, like you have to connect to it. Because what I get, and if you do this, I will only take off half a point, but I will tease you a little bit, is I get people that have the hole over here, and then they'll draw their graph like this. And I'm like, what are you doing? Like, is this the sun? Do you know what I'm saying? Like, you have to incorporate that into the graph, please, for the love of my sanity. And again, if you do it, I'm not going to take off a zillion points. I will just tease you a little bit, okay? Like, make sure you connect. Now, everything that's left, it doesn't really matter what order you do these. I was just going to start with range because it's the first thing. As you scan downwards to upwards, who's getting left out? Like, what values are missing here? 1, good, and the whole, which is 3/2. We're going to leave out 1 and 1.5. You can write 1.5 if you want. I'm just going to go with 3/2 because that's what's written there, but you can put 1.5. I don't care. I like fractions. I'm a fraction person. I don't really like decimals. You're going to be okay. Increasing, decreasing. You just have to read left to right. So what is this graph doing as you read left to right? Decreasing. Increasing is none. What do you write for decreasing? What do you copy over? The domain. Just copy it. You're just blindly copying it. The reason it's the domain is because it's left to right. Yes. If your graph doesn't always increase or always decrease, which can happen, I just don't ask that question. I just won't even put it on there because you would need a calculator and the decimals get really messy. So I just don't ask it. And then where are both of the end behaviors leveling off for this one? 1. Why 1? Because that's correct. These are both going to equal 1. Because it's what? It's the horizontal asymptote. Will it ever touch 1? No, it's just the behavior. So like before, the first thing you would want to do is try to factor this. Don't write this down because this won't work. Common thing when you see the x squared plus 1 is people try to split it like this, but let's have a quick conversation about that. Why is this not going to work? Because of what? Because it's a plus sign. If you multiply a positive and a negative, it would need, if it was x squared minus 1, you could do that. Okay, but that's not going to work. So nothing's going to cancel out. Womp womp. Right? So start with the domain. Who's our troublemaker who's getting kicked out? Who do we not invite to the domain party? Leave out -2. Don't feel bad for -2. He's causing a 0 denominator. Get rid of him. What can -2 now become that we've kicked him out? A whole or vertical asymptote. Which one is he going to become? Vertical asymptote. Why is there no hole? Nothing canceled out. Perfect. And then you can dot in the vertical asymptote. All right, next you would want to do the other asymptote. We have one of them. Let's get the other one. You have to compare the powers. What's the power on the numerator? 2. Denominator 1. 2 is bigger than 1, so it is going to be a slant asymptote. I did, but I didn't do an example of it yet. Now, -2 is going to go in the little box. That's what makes this 0. If you're like, hey, wait, wasn't that our troublemaker? Yeah, exactly. Your troublemaker goes in the little box. And then you get your countdown in order. Hint, it's not in this case. What are we missing up here? Do you see how there's 0x? Okay, so we have 1x squared, no x's, and then a 1. This is why you don't learn slant asymptotes in algebra 2, is because you haven't learned the synthetic division. Do you remember how you guys would just put none for the horizontal, but you didn't learn about slant? That's why, it's because you have to have learned that. All right, so bring down the 1. You guys can kind of just shout out the numbers to me. What's going to be the next column? All right, -2, -2, 4, 5. Guess what? We don't use the remainders at all. It's like this. We're talking about infinity. And again, don't think about it too hard. Like our brains can't really do infinity. But as you go out towards these gigantic numbers, like 1 million, 1 billion, 1 trillion, do you get what I'm saying? The remainder is like a teardrop in the Pacific Ocean. Like it does not have enough weight to like affect the graph at all. Some of you are just staring off into space. It's actually a cool conversation to have. Do you get what I'm saying though? Like it's not influential enough. So we just don't use it. This is going to be y equals. Well, hold on. We had an x squared. We have to start with 1 power less. So 1x minus 2. This is going to be welcome back to Algebra 1 class, but I know that it's been a while, so just listen. Do you remember when like 3 months of your life was y equals mx plus b? Y equals mx plus b, y equals mx plus b. Okay, teaching Algebra 1, that's what we're getting into now. You would start at -2, which would be right here. And your slope is 1, up 1 over 1. So watch, I'm going to start here at -2 and just go up 1 over 1. It's just that it's an asymptote, so you don't want to actually like draw it in, just dot it. And so what's going to happen is instead of, this is so cool, you can disagree, but I'm right. Instead of leveling off flat, it's going to level off like this or like this. Do you get what I'm saying? Like it's pretty gnarly. It is. It's cool. That's just how it works. All right, now we need to go and get some points to plot. So let's do the intercepts. X-intercept, you would set this equal to 0. How would you start solving that? But what's that going to be? 0. So it's really just x squared plus 1 equals 0. And what would you do to start solving that? You would subtract 1. And then you would Square root. What's your square root of -1? I. Can I plot plus and minus? Can I plot a positive or a negative imaginary number here? No, so we would just say none. There aren't any. There aren't any real ones that we can actually put on there. It's not whack, it's just how it turned out. All right, y-intercept, you're gonna plug in 0. Look it, if these x's are 0, just cover them up, they're gone. You get +1 over +2, which is just 1/2. So good enough, we're just gonna put that between 0 and 1, like 1/2, good enough. When in doubt, just make the point larger. And then you can go ahead and draw in your graph. These ones look cool. Here, watch. It's gonna do something like this, like level off at these asymptotes. And then the other part of it is gonna be down here and do something like that. Isn't that so cool? It's cool, I like those ones. It really looks like an hourglass. Yeah, so like this piece up here, I'm just bringing it down here. You're gonna be okay.
That's pretty cool, man.
It really does look like an hourglass to me. I don't know, that's what it looks like. All right, and then the last thing is the end behavior. We don't have a horizontal asymptote for it to level off at. So watch me point to this. If I cover up the middle of the graph, because one year I had somebody say to me, Miss Cole, there's arrows everywhere. I don't know which ones to look at. And I was like, that's valid. Let's think our way around that. Cover up the middle. Where does the left arrow point? Down. So we would put -infinity. Just take, like, literally take your hand and cover up the middle of the graph, and then you'll see which ones are the ends. And then if you look at the right side, again, I'll cover it up. Limit as x goes to +infinity. Where is the right arrow going? Good, up. So you would say +infinity. The left side goes down and the right side goes up is essentially what we're saying there. Was there a question? I say make a face of that. So, okay. All right, we're just gonna try one more. Before you start, you're going to need to factor that. This one does actually factor. So can you guys with your group just try and do that real quick and then like share with each other? You're gonna be okay. Make that a little bit more even there.
I think I said by default, it's -1.
Yeah, -1.
-1 and 2.
Good. Did you get x plus 2, x minus 1?
Yeah.
Sweet, you're all awesome. All right, who is our troublemaker that's getting kicked out? Who is not invited to the domain party? 1, leave out 1. 1 is a problem.
Yeah, we don't like one.
Poor 1. Actually, not poor 1. Don't feel bad for 1. 1 is causing problems. So what can 1 become now?
Oh, it's the one that's being.
Hold on. It can be a whole or a vertical asymptote, but it is going to be the whole. Why is it going to become the whole?
X minus 1.
Cancels out. So it's going to be 1 something. How do you get the something? Plug in 1. If you plug in 1, well, the denominator is really just 1. If you want to even just rewrite this as x plus 2. So it'd just be 3. So you get a whole at 1, 3. So you put a little donut there. Remember when we connect it, you have to connect to that though. Don't just leave it floating out in space. Now our only troublemaker was 1 and 1 became a whole. So there won't be a vertical asymptote. It can't be both. It can only be one or the other. Where did I suggest you go next? After you do those 3 things. Yeah, we're going to do the other asymptote. Compare the powers. What's this power? 2. This one is 1. This is greater, so it is slant. We're going to do our synthetic division. What goes in the little box? 1. If you're like, hey, that's our troublemaker. Yeah. Is our countdown okay this time? Yeah, countdown's good. It'll just be 1. You're right. Countdown is 1, 1, -2. And then just go ahead and divide that out. I'm not going to give you more than 3. And what's interesting about that remainder? It's 0. Now, we wouldn't have used it anyway, but that is going to come up, okay? Now, when you go to dot this in, or actually, let's write it on the line. It's going to be y equals 1x, good, and then, heard somebody say it over here, x plus 2. So y equals mx plus b. Make your Algebra 1 teacher proud, okay? You would start at 2, which is right here. What? Yeah, I know, isn't that crazy? Because it goes up 1 over 1. So if you dot it in, it goes through the hole. That's weird. I'll explain why. Just hold on. It looks crazy right now. It's just like a dotted line with a hole in it. All right, then we want to get some points to plot. So we would go back and do the intercepts. X-intercept. You would need to set this equal to 0. If you set this equal to 0, what do you get? -2. So -2, 0. What do you notice about that when you go to put it on the graph? It's on the asymptote, which is strange. And when you go to do the y-intercept, you would plug in 0. If you plug in 0 for x, what do you get? You get 2. And when you go to plot that, where is it? It's on the asymptote. The graph actually is the asymptote. And the reason it worked out perfectly is because the remainder was nothing. There was like no error, so to speak. It's a line with a hole in it. And when I taught Algebra 2, I taught the ones that were a line with a hole in it. Did you see that last year? Like a line with a hole? I don't know, you're asking me to remember last year. I know, it's crazy. Then it like works out perfect. Isn't that cool? It's so cool, guys. It's neat. Disagree, but I'm right. All right, range. Sweeping downwards to upwards. Who is getting kicked out of the range party? 3. Why 3? There's a hole there. It's missing. Like it's literally not that we pulled it out. Oh, what kind of discontinuity is that? Removable. Reading left to right. Are we increasing or decreasing? Good. Increasing, so decreasing is none. And what do you copy over for increasing? The domain. Just copy over the domain. And then end behavior. Where is the left arrow pointing? Negative infinity. The left side goes down. And then the right side goes up.